let's go ahead and get started. What do you want to talk about? R equals sine 2 theta and find the highest point. Okay, find the y coordinate of highest point. Okay, how do we do that? So we know what this thing looks like. Is this like one of the rows? I think it's like a flower, right? I don't know if somebody told me that. So I think back to Calc 1. This is something you did quite a lot of, not in Polar, but you did this. How do you find a maximum of a function? What's that? Right. So what do you do with the derivative once you have it? Set it equal to 0. So it's the same thing here. I want to find where dy dx is equal to 0. Or for us, I could really settle for this. I can find the dy d theta equal to 0. So how could I find dy d theta based on this function? I'm not giving you y, but let me get it. How is y related to things in polar coordinates? Right, so here's my, basically this point right here, I can represent in two ways, r theta or xy. If I want to relate y to r and theta, it'll be y equals r sine theta. In general, that's true. For this particular problem, r sine theta is equal to sine 2 theta sine theta. So I can take that derivative with respect to theta, so that's 0. So we're good with the logic of why we're approaching it this way. Okay. So what's that derivative going to be? What is dy d theta? What's the derivative of sine 2 theta? 2 sine 2 theta? 2 cosine 2 theta times sine theta plus sine 2 theta cosine theta. Does anything? Okay, where should we go from here? We got an equation, but I think it's pretty complicated to solve the way, especially the way it looks right now. Yeah, so there are a couple double angle identities we should use. Basically, to get this thing all in terms of a single angle. Right now, I got theta and 2 theta. I think I can make everything only theta. So for now, I'm going to leave the cosine 2 theta open because I'm not really, let's see what the other one looks like. There is an identity for sine 2 theta. There's only one, so 2 sine theta, cosine theta. Cosine theta. This comes to be 2 sine theta, cosine squared theta. I think because of the way this right-hand term shook out, I would go with this identity for cosine 2 theta. So foiling that out, or extending that, I get what? 4 cosine squared theta sine theta minus 2 sine theta. I guess some stuff that combines, right? So 6 sine theta cosine squared theta minus 2 sine theta equals 0. Let me pause there for a second. Any questions on anything that's gone on so far? Okay, so from there, how do we solve that? Factor the sine. I'm gonna factor out 2 as well. So 2 sine theta times what? 3 cosine squared theta minus 1 equals 0. So from there, I can break that up into 2 equations, right? 2 sine theta equals 0. So let's actually solve that one first. Where is sine theta equals 0? Zero pi, 2 pi, and so on, right? Maybe this is a good time to bring this up. So based on our function, we have r equals sine 2 theta. Actually, let's just look between 0 and 2 pi. What happens with the other equation? So I got 3 cosine squared theta minus 1 equals 0. If I solve that, I end up getting this cosine of theta equals plus or minus 1 over square root, which is not an angle I think we need to calculate to figure out what that angle is, right? The inverse cosine of 1 over radical 2. So the cosine you have, it's radical 3 over 2 is the one you could access. This one's not. So I think I'm going to stop here, but what I will say is this. So we have a bunch of candidates for angles to try. I don't think all of them are going to give you the right answers, right? So how many angles do I have? I have 0, I have pi, I have 2 pi. There are going to be 4 angles to solve this equation here. So I have like 7 different angles to test, but how do I test them? So let's back up. The way we found all these angles is we set dy d theta equals 0, right? So I don't know what this curve looks like without graphing it, but basically I know what happens at these points. I kind of have this situation, right? So I could have maximum values, I could have minimum values. Some of those points that are probably minimums, and they're not going to make sense for answering the question. So what do you really have to do with all those angles to figure out what your answer actually is? Now, dy dx has to be equal to 0. I mean, at least dy d theta is, because that's how we found these points, right? You can do that, but it's not really going to help you answer the question. I mean, so you can do that. It'll tell you maybe you can eliminate some of these, but you're really looking for the y coordinate, right? You can take those angles and plug them into this thing here. Basically, the biggest y values you get. It says y coordinate at the highest point, so I'm guessing there are multiple that all share the same level. Would it help if we look at this thing?